When considering electrical installations in wet locations, understanding the National Electrical Code, or NEC, is crucial. The question specifically addresses lighting above a sink and references section 410.4d, which primarily discusses bathtub and shower areas. However, it's important to examine the exceptions within that section to fully understand the requirements. Section 410.4d focuses on the specific conditions within bathtub and shower areas, which are classified as wet locations due to the potential for water exposure. This section of the code aims to minimize electrical hazards in these environments. Now, let's delve into exception number 1 of section 410.4d. This exception states that fixtures with a faceplate that extends at least 6 inches beyond the edge of the tub or shower stall are permitted to be installed within a Zone 3 or Zone 4 wet location. This exception is designed to provide a degree of flexibility while maintaining safety. The key here is the 6-inch faceplate extension, which helps to protect the fixture from direct water exposure. Zone 3 and Zone 4 wet locations refer to specific areas within and around bathtubs and showers that are defined by their proximity to water sources. These zones help to determine the level of protection required for electrical fixtures. A Zone 3 wet location is generally considered to be outside the immediate vicinity of the tub or shower but still within reach of moisture. A Zone 4 wet location is an area that is subject to splashing or spraying of water. Now, regarding the scenario of a light fixture above a sink, the crucial point is whether the sink area is considered a Zone 3 or Zone 4 wet location. In most cases, the area above a sink is not classified as either of these zones unless it is directly subject to splashing or spraying of water in a manner similar to a shower. Therefore, the 6-inch faceplate requirement stipulated in exception number 1 of section 410.4d typically does not apply to light fixtures installed above sinks. The exception is primarily relevant when fixtures are installed within the immediate vicinity of a bathtub or shower where water exposure is more likely. It is always advisable to consider the specific conditions of the installation location. If there is a possibility of water splashing or spraying onto the fixture above the sink, it would be prudent to use a fixture rated for wet locations or to take other measures to protect the fixture from moisture. Here are key factors to consider when determining the appropriate electrical installation practices in wet locations. Firstly, identify whether the location is indeed classified as a wet location. Secondly, review the specific requirements outlined in the NEC for wet locations. Thirdly, consider the potential for water exposure and select fixtures and wiring methods accordingly. Fourthly, if applicable, adhere to the requirements of exception number 1 of section 410.4d regarding the 6-inch faceplate extension. And fifthly, when in doubt, consult with a qualified electrical inspector to ensure compliance with all applicable codes and regulations. Now let's delve a little further into some additional considerations. The NEC provides detailed guidelines for electrical installations in various types of locations, including wet, damp, and dry locations. Understanding these classifications is essential for ensuring electrical safety. A wet location is defined as an area subject to saturation with water or other liquids, such as areas exposed to weather, car washes, and unprotected locations. A damp location is defined as an area that is partially protected from weather and is subject to moderate degrees of moisture, such as some basements, barns, and cold storage warehouses. A dry location is defined as an area that is not normally subject to dampness or wetness. The type of location determines the type of electrical equipment and wiring methods that are permitted. In wet locations, for example, it is necessary to use waterproof or watertight fixtures and wiring methods to prevent water from entering electrical components and causing hazards. In damp locations, moisture-resistant equipment and wiring methods are typically required. In dry locations, standard electrical equipment and wiring methods are generally sufficient. When selecting lighting fixtures for wet locations, it is important to choose fixtures that are specifically designed and labeled for such use. These fixtures are typically constructed with materials that are resistant to corrosion and water damage, and they are sealed to prevent water from entering the fixture. In addition, the wiring connections within the fixture should be made using waterproof connectors to ensure a watertight seal. The NEC also specifies requirements for the installation of electrical boxes in wet locations. Electrical boxes must be made of corrosion-resistant materials, such as stainless steel or non-metallic materials, and they must be installed in a manner that prevents water from entering the box. In addition, any openings in the box, such as those for wiring, must be sealed with waterproof sealant to prevent water ingress. Wiring methods in wet locations must also be designed to withstand exposure to water and other liquids. Conduit, which is a type of protective tubing used to enclose electrical wiring, is often used in wet locations to provide a physical barrier against water and other environmental factors. When using conduit in wet locations, it is important to use watertight fittings and connectors to ensure a watertight seal. The NEC also specifies requirements for the grounding of electrical equipment in wet locations. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow in the event of an electrical fault. This helps to protect people from electric shock and to prevent damage to equipment. In wet locations, it is especially important to ensure that electrical equipment is properly grounded, as water can increase the risk of electric shock. The NEC provides detailed guidelines for grounding electrical equipment, including the size and type of grounding conductors that are required. Furthermore, the NEC addresses the use of ground fault circuit interrupters, or GFCIs, in wet locations. A GFCI is a device that monitors the flow of current in a circuit and is designed to quickly disconnect power if it detects a ground fault. GFCIs are required in many wet locations, such as bathrooms, kitchens, and outdoor areas, to protect people from electric shock. The NEC specifies the types of circuits that are required to be GFCI protected and the locations where GFCIs must be installed. It is important to note that the NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements carefully to ensure the safety of electrical installations. In addition to the NEC, many local jurisdictions also have their own electrical codes and regulations. These local codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to be aware of and comply with all applicable codes and regulations when performing electrical work. Consulting with a qualified electrical inspector can help to ensure that electrical installations are safe and compliant with all applicable codes and regulations. Electrical inspectors are trained to identify potential hazards and to ensure that electrical work is performed in accordance with industry standards. They can provide valuable guidance and advice on electrical safety matters. In summary, addressing electrical installations in wet locations requires a thorough understanding of the NEC local codes and industry best practices. By following these guidelines and consulting with qualified professionals, it is possible to ensure the safety and reliability of electrical systems in wet environments. When dealing with electrical installations, the avoidance of hazards is paramount. Water and electricity present a potentially lethal combination, making strict adherence to safety protocols non-negotiable. A meticulous approach to planning, installation, and maintenance is essential for mitigating risks. Prior to commencing any electrical work, energizing the circuit is the foremost priority. Employing lockout-tagout procedures ensures that the circuit remains energized throughout the work duration, preventing accidental energization. Verifying the absence of voltage with a reliable testing device is crucial, confirming the circuit's energized state before proceeding. Wearing appropriate personal protective equipment, or PPE, is mandatory. Insulated gloves and safety glasses provide essential protection against electrical shock and potential arc flash incident. Selecting tools specifically designed for electrical work is vital. Insulated tools with non-conductive handles safeguard against accidental contact with live electrical components. Using ladders made of non-conductive materials such as fiberglass minimizes the risk of creating a conductive path. Inspecting electrical equipment and wiring for signs of damage or wear is essential. Replacing damaged or worn components promptly prevents potential hazards. Ensuring proper grounding of electrical systems is crucial. Grounding provides a safe path for fault currents, reducing the risk of electrical shock and equipment damage. Avoiding the use of extension cords as permanent wiring solutions is important. Extension cords are intended for temporary use only and can pose fire hazards if used improperly. Keeping work areas clean and free of clutter minimizes the risk of accidents and ensures a safe working environment. Avoiding working in wet or damp conditions unless absolutely necessary is crucial. Water significantly increases the risk of electrical shock. Seeking guidance from a qualified electrician when unsure about any aspect of electrical work is always prudent. A qualified electrician possesses the knowledge and experience to perform electrical work safely and in compliance with applicable codes. After completing electrical work, thoroughly inspecting the installation ensures that all connections are secure and that the system is functioning correctly. Testing ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FCIs, verifies their proper operation, providing essential protection against electrical hazards. Educating oneself about electrical safety is an ongoing process. Staying informed about the latest codes, regulations, and best practices ensures that electrical work is performed safely and effectively. Furthermore, regular inspections and maintenance of electrical systems help to identify and address potential problems before they escalate into serious hazards. This includes checking for loose connections, frayed wiring, and other signs of wear and tear. By adhering to these safety precautions, electrical professionals and homeowners alike can significantly reduce the risk of electrical accidents and ensure the safety of themselves and others. Electrical safety is a shared responsibility, and a commitment to safety is essential for preventing injuries and saving lives. Remember, electricity is a powerful force that must be treated with respect. By following safety guidelines and exercising caution, you can work with electricity safely and effectively. Always prioritize safety when working with electricity and never hesitate to seek guidance from a qualified electrician when needed. A little extra caution can go a long way in preventing electrical accidents and ensuring a safe working environment.